Hello, IB Bio students. Today we are looking at 11.3, the kidney, and we're going to be looking at selective reabsorption. So just a quick review. Remember that the kidney is composed of nephrons, right? So here we see the structure of the kidney, and then we see that the nephron is that functional unit of the kidney found dispersed within the cortex and the medulla, and it is where the filtering of the blood is going to happen and where the filtrate, which eventually will turn into the urine, is going to be processed to be expelled out of your body. So when we looked at the structure of the nephron, we said that different functions happen at different parts of the nephron, right? So today we're going to focus on this selective reabsorption within the proximal tubule. So remember that last time when we looked at ultrafiltration, we said that the glomerulus is going to, within the Bowman's capsule, is going to filter the blood, right? And then it's going to return some of that clean blood back into your body. But before it does so, there are still some things within the blood that, before it does so, there are still some things within the filtrate that need to be returned back into the blood. So as the filtrate moves from the Bowman's capsule into the proximal tubule, again, some things within the filtrate need to be returned back into the blood. So if you notice here, there's still some artery, capillary, venule attachment here within the proximal convoluted tubule and the distal convoluted tubule for that form of selective reabsorption. So that's what we're going to focus on today. So in selective reabsorption, we see that the proximal convoluted tubules selectively reabsorb useful substances by active transport. So it happens in both the proximal convoluted tubule and the distal convoluted tubule, but the majority of the selective reabsorption is going to happen in the proximal convoluted tubule, which, if you remember, is closer to the Bowman's capsule. So here we see that the proximal convoluted tubule has microvilli cell lining. So in this picture right here, this region right here represents the proximal convoluted tubule. And notice that there are these microvilli lining, right? So microvilli are like these finger-like extensions, and this is going to increase the surface area to allow for greater absorption. One thing about the proximal convoluted tubule is that it's a cell thick, and if you notice that these cells are held together by these tight junctions. So that means that nothing can just squeeze in there because you have these tight junctions here. Let me move here so you can see as well. You have these tight junctions here that prevent anything from just squeezing in there. Okay. Also, you don't see them here, but there's a large number of mitochondria found within the proximal convoluted tubules, and that's because there needs to be energy for active transport here. So substances, as you can see here, and let me move this up a little bit more, substances can move either passively or actively. So we're going to be exploring that. So if this is the proximal convoluted tubule, there are two regions to the tubule. We have this apical membrane region, and this is the region that's closer or facing the lumen region, and in this lumen region is where we find the filtrate, which eventually will turn into urine, right? On this end, we have the basolateral region of the membrane, and this is the region that faces the blood vessel, right here. Okay. So everything that gets returned back to the blood is things that are good, are things that you need in your body, right? So everything that comes back here is good, and everything that remains in the filtrate is eventually going to be urine, right? So these are things that are bad for you. So the tubules are going to reabsorb things like glucose, Okay, so remember we need some healthy levels of glucose in our blood. We need amino acids, we need vitamins and hormones, and we need mineral ions, and we need water. Oops, not this one, that's a bad one, and we need water. So all these things need to be reabsorbed because we don't want to dehydrate, we don't want to lose the glucose homeostasis within our cells, and we don't want to lose these ions, sodium and calcium ions, chloride ions. Now, the one thing that is bad is going to be urea, right? Urea is found in the urine, and that's bad, and that's probably going to stay in the urine, and the filtrate is not going to be filtered back or reabsorbed back. So there's more detail here than what you probably need to know for the curriculum of this class, but there are different ways in which some of these substances can be transported back into the blood. So for example, if you see here, sodium ions are passively diffused through the apical membrane. But here we see a channel or a protein channel that is known as a Symporter. And remember, anytime you have Symport transport, that means that when one substance or ion goes in, there's going to be a couple more that are going to kind of tag along as well. So we see that when sodium is passively transported inside the membrane, we see that amino acids and glucose through that same Symporter channel is going to be actively transported in. Okay. Ions are going to actively be transported in as well through a protein channel called a uniporter, because only these ions are going to be transported. And water is just going to simply diffuse. So of course this is passive diffusion, no energy is required. And here we see water moving in the direction of the blood. Okay. Once these ions are inside the interior or the cytoplasm of the cell, what's going to happen is that as they move from the proximal convoluted, I spelled this backward, proximal convoluted tubule into the blood vessel, they might change the mode in which they transport. So notice here that these ions moved in through active transport, but then they're going to passively diffuse into the blood vessel. Same thing with these amino acids and glucose. Once they're in, they're going to passively diffuse. And then sodium, who passively diffused as well, is going to engage in the sodium-potassium pump, which you might have heard of before. And this is where potassium here is going to actively go inside the cytoplasm of the cell, right? And when it does that, is going to allow for sodium to be actively transported back out. So this happens through a protein channel called an antiporter, because as you have one ion coming in, you have the other one coming out. Okay? Eventually, potassium is going to passively diffuse back out. But pretty much that's what's happening here. Okay. The proximal convoluted tubule is serving as a region for selective reabsorption. Remember, most of this selective reabsorption is happening in the proximal convoluted tubule, even though some of it also happens as well in the distal convoluted tubule. Okay, so that is it for selective reabsorption.